Okay, so the data you should get about the gradient, I think I show you that day. 5, right? This is the equation, right? Okay, so I hope you get the gradient around this value. Okay, uncertainty doesn't matter whatever value you get, but make sure that the decimal place for the uncertainty and the value same. Okay, the value for the gradient must get around 0.048, maybe plus minus 10%. A lot. And the gravity from this data, you should get 820 plus minus 50. As usual, 50 doesn't matter, any value will do. But 820, the 820, go for 3 significant figure, and your answer must be again plus minus 10% of the 820. 10% means what? 900 to 700. How much? 740 to 900. The gravity. Okay, so gravity. Yeah, so gravity must be plus minus 10%. The y-intercept must be 29. All plus minus 10%. Uncertainty is fine. Any number it will do. It doesn't matter. They did not even give marks for the uncertainty. Uncertainty, they say method finding the uncertainty. So how to find the uncertainty? The best fit and the worst fit, right? The best fit gradient, worst fit gradient. We subtract, get the uncertainty for the gradient. Correct? That's the question, right? So gravity. How to get your gravity? Gravity here is sorry. Gravity gradient is 4 pi squared over g. So g is okay plus. You know the gravity you calculate for the case of gravity. For the case of gravity, what you did, you find the gravity by using the best field line and gravity of the worst field line, right? That's one way. Another one way is using the, the gradient is 4 pi, what? 4 pi squared over g, right? So gravity is what? 4 pi squared over m. M is the gradient. So changes of g over g equals to changes of m over m, right? Uncertainty 4 pi squared won't involve in the uncertainty equation. So from here you work out your changes of g, changes of m over m times g. Okay, this g is your the actual the g from the best fit, okay, or the actual gravity best fit. So usually in the mark scheme, you can go for best fit gravity and the worst fit gravity, and you subtract, get the changes of g, right? In mark scheme, normally they put this working. Okay, so in a real mark scheme, you say they go for the for the gravity, for the gradient and the y-intercept, best fit gradient, worst fit gradient, subtract, you get the changes for the gradient. That's fine. They give the working like that. But when it comes to after that, like you see the application, okay, how do you make use of the gradient and the intercept? In this case, you're going to use the gradient and intercept to find the gravity, right? To find that level, when it comes to that level, they normally give working like this. They go for the changes of G, right? The uncertainty formula with the gradient or intercept, and get the uncertainty for the gravity from this time. So I think we follow the mark scheme. I prefer you go for the uncertainty equation. When you use this, after your gradient and the y-intercept, the following calculations. Okay, following calculation. You use the uncertainty formula and you work on it. So here your changes of m, is your uncertainty for the gradient, earlier. M is your gradient. Gravity, this G, you have to calculate first how to find the gravity. Use the formula. So of course, G is what? 4 pi squared over G, M. So find the actual G, the actual G is what? 4 pi squared. The gradient you put what? Your original gradient. In this case, what is the gradient I get? 0.048. Yeah, so you put that 0.048 and you get only the actual, the gravity, the real gravity. The uncertainty, for the case of uncertainty, for the case of uncertainty, use the formula. Okay, don't go for like just now you did the actual gravity. Don't go for the worst gravity. You go for the worst gravity, then you subtract, find the changes of G, right? Okay, that method. It's not wrong, but mark scheme always go for this equation. So we follow them to be safe side. Okay. Okay. Any question from this experiment? Anyone? Okay. So let's proceed with another style of a question like this. Okay. So let's go to the new one. The new one. We move down. Okay, yeah, we go to this C3. C3 is little different from the earlier one. Why? It involving ln and log. Okay, when the equation involving ln and log, it's slightly different how to treat the uncertainty. Okay. Okay, first, let's work together. Okay, look at the C3. This is about capacitor. The voltage across a capacitor with the discharging is V equals to V naught E negative T over CR. Okay, this is actual discharging formula for the capacitor, which is not in your syllabus, but they can put it in the practical, do the graph. Okay, so again, let me go. So for a capacitor, if you put V versus the time for a capacitor which completely charged, maybe for 5 volt, it will be discharged exponentially. It will be discharged exponentially because of existence of the E exponent. Okay. Now this is the data they obtained, the discharging. The 2.6 volt was dropped to 1.2 volt in 33 seconds. Okay, 33 seconds. Okay, let's scroll down. The first question. What's your answer? Use your linear law to explain this. Explain why plotting a graph of ln V against T would enable you to confirm whether the relationship between the V and T is valid, the data in the table. Okay, why plotting ln V versus T would enable us to confirm the relationship. So what you have to tell? By plotting ln V versus T, what gradient, what is the intercept? Therefore, would enable us to confirm the relation. So you have to get what is the gradient and what is the intercept. So it's linear law. Okay. So how do you do this? So V equals to E naught E negative T R C. I think you've done this before, right? You know, at maths. Okay. Maths. So yeah, you want to bring down the power. You bring ln to both sides, right? Ln E, then ln E naught plus, sorry, not plus, negative T over RC, right? Ln E is become 1, right? The power will come down. This is the max. Okay. Do you learn linear law in your A levels again? A levels max? Do you learn linear law? You learn again. Okay. Okay, so yeah, so this is the final equation. So ln V equals to negative T over RC plus ln V naught. Okay. So by plotting ln V versus what? T, compare with y equals to mx plus c. So what is the gradient? Negative 1 over RC. And the y-intercept is what? Ln V naught. So how do you write at the bottom? You write this final appearance of the equation. You show this final appearance of the equation. The final, no need to show the entire derivation. The final appearance. Okay. So you write there ln V equals to negative T over RC plus ln V naught. Okay, then you see by plotting ln V versus T, we would by obtaining a straight line where the gradient is negative 1 over RC and the y-intercept ln V naught would enable us to confirm the relationship. Okay. So you show this equation, then comma you say by obtaining a straight line. By obtaining a straight line where gradient equals to negative 1 over RC, 1 mark. They see gradient is negative 1 over RC, get mark. And y-intercept ln V naught, that's together, 1 mark, would enable us to confirm the relationship. Okay, now we move on. Okay, now as usual, okay, part B. Calculate and record the value of ln V and T. Include the absolute error in ln V. What do you want? You want the ln V and T. T is already there. So ln V and changes of ln V needed. So this is only one column provided. So what do you do? You put the ln V and changes of ln V together. Okay. Okay, so you put here, so ln V plus minus changes of ln V together. Okay. Okay, when you do ln or log, do you have any unit? No unit. So no slash any unit. Okay. Okay. I made a mistake. Sorry. The mistake is the unit for the ln. So the mistake is ln V slash V. Plus minus changes of ln V slash V. The unit must be the unit for the volt needed. Unit for the volt needed. Okay. Okay. sometimes ln x slash, is it the x, is it length, let's say, is it a meter or centimeter, you must put slash the unit. Okay, sorry, not this one, the unit. Okay, so finding the ln V, no problem. What is the ln V for the first value? 0.56. Okay, let's say for the ln V for the first data, ln 2.6, so 0.56 is it? 0.96. Good, 0.96. How many significant figure to be used? This is how many significant figure? 2 significant figure. So yeah, 0.96. This is 2 significant figure. Okay. Okay, so plus minus. Okay, now the problem is the changes of ln V. And come to ln and log, you cannot form equation. You don't have technique to form equation. Okay, we only use the second technique. What is the second technique? The actual minus the minimum. That's we use for ln and log. We cannot form equation. Equation only for without log and ln. Okay. So here for the ln V, changes of ln V, the actual ln V minus the minimum ln V. Or can go for maximum ln V, both acceptable. Actual minus minimum or actual minus maximum. You get negative, but still it's negative, plus minus 1. We just want the magnitude. So I think we stick with one ln actual ln V minus the minimum ln V. Minimum ln V. So for this case, how much you get for the uncertainty for this? So let me. So what ln 2.6 minus the minimum is what? Ln the smaller number, because plus minus 0.11, so 2.5, 0.07, so same decimal place, so 0.07, 08, 08, okay. So for the case of ln and log, actual minus minimum, your uncertainty. Okay. So now, can you get the entire data? This is what ln. Try to work out first. It's the one, right? Oh, 0.004 or not 08, 0.04. Ln 2.6 minus ln 2.5, right? 0.04. Calculate this, you get this data. You ask any problem with the data? Any part slightly different? Okay. So here, all data, the keyword they're going to check the significant figure. They're going to check here the significant figure. The significant figure must follow the significant figure as the source, as usual. Yeah, this is all are 2SF, so all of them are 2SF. So this should be 2SF. But there is sometimes just extra. Let's say there is a data. Let's say, for example, you have a data of 25.2. Let's say I put a data here. 25.2. 25.2. Okay, 25.2. What is the ln value you get? Anyone? Ln 25.2. 3.23. That's all. 226. Okay. So 3.226 something, right? Okay. So the trap here is how many significant is this? This is 3 significant figure. So this is how many significant figure? 4. The first digit significant not counted for ln and log. Only the after decimal, this significant is counted. So you suppose write here, because this is 3SF, you write 3.226. 3.226. This is considered 3.226 is considered as 3 significant figure for log and ln. Why? So for example, why they never consider the first digit as a significant is, for example, I think again your additional maths knowledge, you see log 25.2, you got how much? 3.226. Log 252, you'll get how much? You get, check for me, log 252, you get the same. The front digit, I think, different. Two point 2.4. Log 352. Log 25.2, you got 3.226. Yeah. Log. Go for log first. How much you get? Log 252. Oh, this is different. Right? Yeah. Okay. First one is what? First one is 1.4. 01. Okay, the 252. 2.401. Can you predict log 2520 will be how much? 3.401 and so on, right? 25200 will be 4.401. All right. So the front number is like the power, So they never consider it as a significant figure. Significant figure is after that. Log and ln same rule. Okay, log and ln same rule. You are lucky here. Is 2 decimal because front is 0. So front not taken to be a significant figure, but suddenly, let's say you got 25.2, front got number 3 point, like just now, 1.401. Please don't count this one as your significant figure, only for lock and lock. Okay, the significant is after that, after the point. Okay, there is 1 year came out. 1 year came out. I don't know what log they did log. They got the reading like the values seem to be 3 significant figure, and the reading they got is 1.0264 something. Okay, so this is 3 significant figure. Okay, 3 significant figure. So one is of course not counted. This log for the case of log. One of course not counted. 0 counted or not. They count as significant figure. So that means here you should not write for just 026. 0 count as significant figure. 0 is significant figure. After the decimal. After the decimal, any other either 0 or number of course is significant. If 0 is still considered significant figure. Okay, I'm telling what the masking gives us. Okay, so the front number definitely not counted for the significant figure. Decimal, after decimal, 0 still considered significant. Okay, let's say you got 001. 001 consider after the decimal 3 significant figure. Okay, only for log and long. Only for log and long. Okay. Okay, class. So now for this case, that problem doesn't arise because the front is 0. Okay. So you got the data, I think. Any problem with the data? Okay, no problem with the data. Come on, plot the graph. The graph you need to plot. The axis you need to choose is the above here. Okay, yeah. The y-axis is 0 to 1. Each box is 0.1. Okay, your graph, because your y-axis is ln v. Ln v start with 0. Ln v start with 0, 0.0. Every one box must be 0.1. So that means, yeah, 0.1. And the box is like 0.2 and so on. In a case of T, again start with 0.0. This is also 0.0. Every one box, so much? 5. It's 5. So 5.0, 10.0, and so on. Okay, I give you 15 minutes. Draw the graph, draw the best speed, worst speed. So after you plot, get your gradient and your y-intercept, okay, with its uncertainty. That's with gradient, with gradient, subtract is your uncertainty. Okay? Okay, so you should get these answers. Okay, do your gradient and y-intercept. Okay. See, after that, let's we do together. If you know how to do, go ahead. After your gradient y-intercept, the following calculation, if they ask for the values, you have to use the uncertainty formulas. You show the uncertainty formula. Like here, they want the capacitance. Okay, let me go to the question. So, gradient of best fit. So, gradient of first fit. Get your gradient. Y2 minus y1, x2 minus x1. Get your reading. Get your reading. Finally, the gradient is its value. So this x and y. It should be the x. The error must be x minus 1. Okay, verse field line, make sure the verse field line, bottom to the top, make sure it passes all the error bar. You never pass the error bar, bottom you hold it like a pivot, just rotate it, root the ruler a little down until it passes the error bar, which never passed before. Okay, if you draw a verse field which never passed one of the error bar, you lose mark for the verse field. Okay. 0.95 0.7 in plus minus 10% tolerance.
Because the error is x. You get the median and median minus 0.9 the worst bit. Or just using the
So what for the
to get the plus minus median or median.
uncertainty for the gradient?
Yeah.
Yeah, the best fit gradient minus the worst fit gradient. The difference is your uncertainty.
I got 0.1.
You got 0.12. Doesn't matter. That doesn't matter. The important is your value. Value is it within plus minus 10%. That means the gradient value is what? 0.025, right?
Yeah, I got that.
That's fine. That's the one they're going to check.
Uncertainty.
Uncertainty, seeing decimal, uncertainty in the mark scheme, they put the method of getting the uncertainty. Best fit minus worst fit, you done.
Oh, yeah.
That's your error, I get marked there. And make sure the decimal place same. This is 0.0025, the error is 0.002. You got what? 0.01. 0.012. 0.012, doesn't matter. 0.012 no, 0.012. Okay, class, the important is this value. Important is your values, these values. This value must be within 10%. Your uncertainty, you get anything, any different number is fine. Okay? Uncertainty they give for the method finding the uncertainty. That's it. Okay, the last part, if you can know how to do, you have to use the uncertainty formula. Uncertainty changes of C over C equals to what? You have to write that first. Then find the changes of C. So the capacitance, last part. Use your second topic knowledge. First, get your gradient and one intercept first. Give you another 2 minutes. If you're done, then we can go for capacitance.
Do you know how many significant figures?
Oh,
Sure.
great. After you graph all three SF.
Oh, sure.
Go for three. Definitely correct.
Oh, then so like this.
Ah,
Then there's uncertainty also. 3 significant.
Very last, yeah, the answer given gradient y-intercept for two significant figure, right? I think you standardize for 3SF. 3SF definitely correct. Okay, you go for 3SF. After the graph, all you go for 3SF. You won't get wrong. That means here 0.025, you can add another one digit if you want. 3SF is standardized, you won't get wrong. You will definitely fall under 3SF. Okay, after the graph, you go for 3SF, it's safe.
Is that 0.002 or 0.015?
0.001 or 0.0015. Same decimal. Okay, so I believe all of you got your y-intercept and gradient. You draw the best field line and the worst field line. You got a gradient and the y-intercept. Okay, let's we go for the last part.
Okay, I found the gradient already, but how many do I need to do? I follow like the 2SF?
Go for 3SF.
Why 3SF? But isn't this like 2SF? Oh, this is kind of like 3. But I thought you said like what's the smallest SF?
Yeah, correct. Smaller size, or one extra.
So what do you suggest?
Actually, smaller size, but you go for 3SF and you go for 3.
Okay.
Okay, you have to go for 3.
Okay, then what about the uncertainty? Do you minus it both?
Yeah, minus both.
Gradient minus both, and that's the uncertainty.
That's uncertainty, but the decimal of uncertainty must be same as
The
the actual
value.
value.
Less than 40, sir.
Yeah.
Okay.
Class, so let's we go for the last part, capacitance. Okay, go to the question. So, okay, so all of you got I put a common number here. Y-intercept, let's say you got A plus minus B. Gradient you got C plus minus D. Okay, I go here. They want capacitance. Capacitance, but the resistance got also as error, 5%. So they want the C value. So what is the C formula? Capacitance formula? C, your gradient, you get your C from how? Your gradient, right? Your gradient is negative 1 over RC. Correct? Your gradient is negative 1 over RC. So we use that. Go over here. So the gradient is negative 1 over RC. Okay, so what is your C? C is negative 1 over gradient times R, correct? So you write the uncertainty for this from this formula. Changes of C over C will be what? Gradient also has uncertainty, R also having uncertainty now. So both going to affect the capacitance value. So yeah, changes of M over M plus changes of R over R. You have to show this. This will give you mark. Okay. And find the changes of C. Before that, you need to find your C first, right? The changes of C is what? Changes of M over M plus changes of R over R times with C. So changes of M over M plus changes of R over R, put all the values you know above. Changes of M over M is what? Changes of M over M is your DOC lah, right? According to my data, I just put DOC or whatever DOC, right? And changes of R over R is what? It's 5%. 5% in fractional how much? 0.05. Okay. C you have to calculate earlier. How do you get your C? C from the actual value. How do you get your C? The C you can calculate by using. So you have to calculate the C first. C is what? C is negative 1 over MR. So negative 1. M is what? The gradient. The actual gradient. Use the actual gradient C times the C value. I put it C. C. Then your R is 5,000. The actual value. Put the actual value. Find the actual capacitance. How much? That C you have to use here. Okay, whatever value you got here, this value you have to put it here. Oh no, I just put a number A plus minus B. I don't know what value you got. Like you got your values right. So find your C first with the actual value of M and R. Then write the uncertainty formula for C. Find the uncertainty for the C. So changes of M over M is like here I put gradient C plus minus D, so this is D over C. The changes of R over R is 5%, is fractional. So 5% change to fractional is divided by 100, right? 0.05. Changes of R over R, I put 0.05.
What's the answer?
This method. And says how much? It says 8 plus minus 1. As usual, the error is not that important. The value 8 plus minus 10%. The error, they're going to check the method only. As I said, 8 plus minus 1, right? They don't care about 1. Maybe the 1 kind of could be 2 or 3. They don't really care. The mark scheme they put, what is the method? The method is the formula, changes of C over C equals to changes of M over M plus changes of R. You wrote that, get mark. The method of finding the changes of C, that's given mark. So marks given for this, and this given 1 mark, maybe, okay, this is the main one, and this is the main one.
That's it. 8 plus minus 1. I got like this.
10.81. 852 decimal. So your capacitance also gives 3 significant figure. What do you got? 3SF. Look for 3SF. 8 point something. Your C you put 3SF. After the graph, all go for 3SF. Oh, cannot. But majority won't go for 1 SF. I think you will be like 2 SF normally. So do you get 1 SF from the answer? 3 SF. You get from the graph how much? 2 SF. 1x. Yeah? Yeah, out of the box. So how much you get? 0.9, 0.955. So 3 SF. Yeah. That's your what? That's your 3 SF. What is the value they give? 0.9. Yeah, okay, correct. Your error have to be the same decimal place. Yeah, then it will be 3 decimal places, right? First, standardize after you graph all the answers, you go for 3 SF. It won't get wrong. Okay, some or other it will fall to 3 SF. 3 SF will be included. Okay, here you see the C given 1 SF, but write 3 SF, 8 point something. 3 SF. Go for 3 SF, all answers. Okay, so this 8. So all the answers go for the answers, the answers, the actual answers, all the actual answers. My suggestion, all go for 3 significant figure. You won't get wrong. So 8, right? 8 point something. 3 SF. Consider 3 SF. Only for log. Log means for your log error. For your log value. On the table non-B, right? On this, we got 0.0 something. That's 0 counted as significant. But here, get back to the whole idea. Okay, class, so this is the technique. So hope you use this technique. See, y-intercept gradient, use the uncertainty formula to get the uncertainty for the following questions. Okay. So after get your changes of C here, then of course you can write C plus changes of C. So this go for 3 SF. Okay, let's say 8.45, let's say, plus minus. The uncertainty give the same decimal place as this number. This is 2 decimal place. Maybe you can write 0.12. I don't know how much you got. If it's you got 0.1 to 0.12, like that, same decimal place. Error can go more than 1 significant figure now. Okay. And of course, please write the unit. Unit. Write the unit. Okay, unit like 1 mark. And range, of course, right? They might give 1 mark. unit for this case is how much? Capacitor. So farad, right? Your gradient is your gradient, what unit? Your gradient, you plot ln V versus time, right? The gradient is per second. Gradient is per second. Your R is in ohms. So then your C will be in farad, F. Here they converted to millifarad. Farad, how much you get? Farad value, how much you get? I think you should get 0.00 something. 0.008. Yeah, so if we change, it become millifarad, become around 8, right? Not 8. So you can leave it as farad if you want, then it could be 0.008 something, right, in 3 significant figures. So 0.008 something something, very significant. Class, any questions? Any part you don't understand? Okay, just now someone asked me here, let's say your answer you got 0.00843, let's say. So plus minus, let's say 0. So you need to put a lot of decimal place because it's in farad. Okay. So here this value, so these two zeros counted as significant figure? No, not for this. This is use the whole idea. Only the 00 counted as significant figure in the table when you go for ln that value, ln V. Ln V, the 0 after the decimal is counted as significant figure. You come to this calculation solve, after decimal point, you have 0, that's not significant.
For this, I get like 1.47. So for here, I need to write 1.47 or 1.
So 1.47. Oh, you got 1.47. Oh,
So
yeah.
we don't have to follow the rule that only one significant.
Yeah, you can go for 1.47.
So just follow the decimal point.
Yeah, because in mark scheme, not even put enough. The error can go more than one answer. Allowed.
Here, do we have to like round off? Because like the answer given is 0.04, but calculated is like 0.046 something. So do we need to round
Yeah,
off?
0.05.
So it should be 0.05. Double check. So this is something like that, right? Is it correct? Like kind of like that. Because you say you follow decimal.
Yeah, so this is B.
But then the back like that, okay.
Yeah. So how many decimal please?
I
4.
got like 4 decimal place, 1 below. And then like for the decimal, it seems weird to me. So, it's like correct. And the gradient, I got it from the gradient, which is negative, right? And times the 5,000, and I got this answer. So it's like that. And you say 3SI, so I put 3SI.
Yeah.
Then for the error, I did it like that.
Got that. And
But then I put it together, then you want to make it milli, right? So I make it milli, but this one is like, I don't know.
your error is bigger than more than 100%. Something's wrong with the error.
Is it? Okay, the percentage change of error.
So what you put? You change the what? 50 over 5,000.
Right. Changes of
50 over.
over 5,000. And then the C is the one over 1,000.
You get 0.05 for this. Yeah, yeah.
Why 0.05?
5%
Oh,
fraction
the
is
same.
also.
I didn't see.
But you get the same.
I mean 0.05.
250 minus 250 divided by 5,000, how much you get? 25,000. 1 over 20.
But then like the changes of R is not with E, right?
Change of R. Yeah, correct. This is correct.
So like, even though it's like that, it's acceptable.
Exam, they're going to give this mark. This, they say, follow the method, correct? Then you get the mark. I don't
But if
think
my
so, you will
answer is wrong,
penalize.
then like, as long as the method,
It says give mark for the method.
or even the answer is wrong, it's fine.
So the error answer is different is fine. The actual answer must be plus minus 10%. 8.47, right? Must be plus minus 10% with the value they give. The error, now your case is very big.
I also because of my graph.
Ah, your graph, maybe your graph.
Over here. Yeah, it's like a very, this here is like bigger one. Big. So I just connect the lowest to the highest. And this one is big.
Lowest to the?
I got the lowest to the highest.
Or the highest and the lowest.
From lowest to highest, right?
So here, that's your best, this is your best fit.
That's why it's this.
Highest, you go for the lowest higher. Yeah, lowest is here.
Here, it's the.
Oh, this is.
As long as my method is correct. And do you necessarily have to change it to maybe?
No, you can leave it at.
This one like is 0.04, right?
So become 0.05.
Yeah.
Yeah.
Do I have to?
Yeah, no.
We have to. So the answers are all wrong.
Oh, yeah. Oh.
Yeah, it's all 0.0. They all never.
Okay, you need to be rounded. Okay, class. So today, going to give you homework. Okay, please do your C4 and C5 as your homework. C4 and let me check. Yeah, C4 and C5. C4, C5 as your homework. Okay. The scale is already there. C4, the scale is there. Okay, C5 also you have the scale. Okay, scale is already there. Real examination scale is provided. And this is going to be like your exam style. So you don't need to worry about the scale. But now you have to be remember easily the examiner can detect whether you made a mistake or not, because every graph of every candidate must have the same identical graph because the scale is same. So a small mistake in the error bar, they can really very fast they can get you. Okay, so take 2 minutes break, then I continue with the CT scan. Okay, boss. So just about 20 minutes, then we can finish this. Okay, after this you got class, right? 10 o'clock. Okay, so maybe you can have a 10 minutes break. Let me finish this now. Okay, no. Let me finish. After that, you can have 10 minutes before your next class. Okay, CT scan. Okay, CT scan is the last part of quantum physics. Okay, quantum physics. So far, what you learned from the beginning? You learn about photon. All start with photon. Photon. After photon, you learn photoelectric effect. After photoelectric effect, you learn about de Broglie wave particle duality. After de Broglie, we learn about line spectra, the discovery of Neil Bohr that electron got energy level. Okay. After line spectra, we learn about band theory. Band theory, the conduction band and the valence band. Okay, all using the energy level discovered in the quantum physics. Then finally, after band theory, we comes to X-ray. X-ray was explained by using quantum idea, energy levels. Okay. Then end of X-ray is CT scan. Okay, CT scan is on par with MRI, same clarity as MRI, but only bad thing about CT scan is radiation. Too much of radiation. Okay, it uses X-ray. CT scan also X-ray. Okay. So CT scan's full name is computed tomography scanning. Okay, CT, C stands for computed tomography. So that's CT, stands for CT. Okay, if you see the machine of MRI and CT scan, it looks identical. Same like a donut shape, same computer at the side, at the next room. So you can't differentiate. You only can differentiate at the door. They put the magnet sign. Here they put the radiation sign. Okay, because it's radiation. Okay, you see this picture? X-ray tube. Down here is a detector. The detector. Last time we used photographic plate. Now not anymore. We have a digital detector. We can detect the radiation and straight away can produce a digital image. Okay, and send to the doctor. Okay. So this X-ray tube will be rotated in 360. You can go rotate 360. Okay. So this tube. Okay. So this tube take an image first. Then the X-ray tube will located here now. Then it will take an image here. Then the detector also turn. Detector will be here. The detector will be here. The X-ray tube will be here. Kind of like that. It rotates. Okay, rotates 360. So it take. Let's say you have a. Let's say there is a tumor. It takes the image in every angle. Takes every angle. Then the computer collect all the data, form a 3D view. How the tumors looks like in the body, what shape, what is the length, what is the diameter, what is the width, and everything. Okay, the 3D view form by taking X-ray in a different angle. Okay. Okay, so CT image. So CT is Yeah, CT is comparing with MRI. MRI, only advantage of MRI is what? No radiation. Okay, CT scan, radiation. Other than that, all for MRI are minus. Okay, MRI only is no radiation. After that, MRI all are minus one. You have to stay still for a long period of time for MRI. There is a loud sound. Okay, expensive. That's about MRI. CT scan, fast. And the CT scan is very fast. You just go in like taking X-ray. Maybe X-ray you take maybe 5 minutes. This one might take maybe 10 or 15 minutes. You can get the imaging. Okay, and fast, patient friendly. Patient friendly means what? You move a little, it's fine. It still gives the image. MRI you can't move. You have to be stay still. You move, the hydrogen movement going to be distorted. The image going to be distorted. You pay more. So CT scan is patient friendly, able to image a combination of soft tissue and bone and blood vessel. Yeah, it's on par with MRI. Okay, the only thing is radiation. No, got radiation, also radiation. Okay, so that's the important part you need to know from here. Okay, so it is also preferred method for diagnosing lung, liver, and pancreas cancer. We use CT scan. Okay. Okay, so the shape remains the same as MRI. Okay, but the problem is the dye they're going to inject. Okay, it's very, what do you call it? Can be allergic to your body. Okay, once I think a few years back I went for I got a neck pain, so I went for a neck and they did the brain scan. So went for CT scan. So CT scan is MRI. I spent around 20 to 25 minutes. I'm okay with MRI. The sound is fine for me. It's just moving a little here and there. Then okay, done. But CT scan, I suffered. CT scan, they brought me in. I just spent a very short period of time. But suddenly they already inject me with the dye. The dye goes into my body. I feel so hot. After that, it's fine. When I come out, I suffered with allergic for 1 year. 1 year of allergic. No. So 1 year I got that rashes. Okay, allergic here and there for 1 year.
I go for MRI for 2 hours.
2 hours. For what? For 2 hours. When? Long time ago. Yeah. Last year. Oh. For me, around 30 minutes. 30 minutes, less than 30 minutes. Do they inject dye?
No.
Or dye? Because MRI also requires dye. If they can't see clearly, they have to inject dye. Yeah, suffering MRI. You move a little, you pay more. Okay. So it's I go straight to the point now. What required for A levels? Okay. The part B is what? The part B, helical CT scanning. Helical CT scanning means the tube will rotate. The body will move in. That means maybe you scan the first circumference, the first part. And when your body moves in, the imaging will be in terms of like a elliptical imaging. Okay, so you can take the entire body and it takes scanning. So it will rotate, at the same time your body will move to the left. Okay, all right. Okay, so I straight to the point. This is all for you to read. I'm not going to teach you this. The important is this is not in your syllabus but extra information. Okay, the important is this part. Okay. CT scan, the computer assume your body part in terms of, you break your body part into voxels, and each voxels has some pixel value, we call it pixel. The intensity it absorbs, pixel value. So In exam, they will ask you to calculate this pixel value. Okay. This is like, imagine this is the body. It's the body that divided into 4 parts by the computer, 4 voxels. 4 voxels. The X-ray was shined horizontally. And the X-ray is shined horizontally. The 4N1, we can see the amount of intensity absorbed by the medium. Like maybe 7 is the bone. Maybe 7 is bone. Okay, you are lying down. They shine from the side. It passes through the maybe backbone or what backbone. When you reach the backbone is 7. 7, the X-ray absorb the most. And after that, the earlier maybe your soft tissue absorb little. So how much of absorption of X-ray done? More the pixel value will be. Okay, the computer will record it. So when X-ray is shined from the horizontal, the 4 and 1, this intensity will be added, become 5 and 9. 4 plus 1 become 5, because in the side bone absorbs 7 and the soft tissue at the beginning absorbs 2. So when you see from the side 2 plus 7, total absorption like 9. It will be 9. Okay, the pixel value. So the computer going to imagine that is like 59. You're going to read like 5599. 5599. That means when you shine the X-ray at the side, the imaging on the screen will be, they can't differentiate the bone and the soft tissue, because bone and soft tissue side by side, and they view from here, one after another. So both regions will look the same contrast. 5 will be the same contrast. You can't differentiate within the bone and the soft tissue because view from the side. Okay, the bone and the soft tissue can be a little clearer when you put the X-ray here. When you put the shine here, then these two, what you call intensity might be slightly different. Okay, then you can see the both differences in the tissue. Okay, so the computer, how we make the differences in the tissue in terms of contrast is the pixel number. Pixel number. Okay, so when you shine from the horizontal, 5599. In exam, they will ask you to write this number. Just simply add 4 plus 1 is 5, 2 plus 7 is 9. So it's all going to be 5599. Then the X-ray will be shine at 45 degrees. So same body, the original body is 4127. Now when the X-ray is shine here, the 1 going to be total 1 value here. The second ray which passes through the 4 and 7 will accumulate to 11, and the 2 will be total is 2 when struck at the X-ray at the side. So the pixel will be accumulated if both are overlapping. Okay, now this 1, 2, 11, 1, the new pixel, the accumulation will be added on top of the pixel you got earlier. 5599, when do you get it? The earlier first transmission. Transmission, this is the pixel accumulation. The second one, this pixel will be added to 5599. So 1 going to add here, become 6, and the 11 going to add here and also here, become 16 and 20, and 2 will be added here, become 11. Become 11. So this is how the computer remember the numbers. You just keep on adding the pixels. Okay. Then when you go to vertically up, the same body with 4127 pixels value. Shine, what happened? You got total 8. Here will be 6. The 6 and 8 will be added to the recent pixel addition. 16, 6, 11, 20. Where do you get? Yeah. So this pixel will be added for the 6 and 8. So this will be 8 plus 6 and 8 plus 20. So become 14 and 28. Then 6 as usual at here and forms 22 and 17. So this X-ray vertically up. You get this, the total pixel now. Then shine at the under 35 clockwise. So you get 4, 3, 7, the accumulation. Here is 4, here 1 and 2 is become 3, 7 is 7. So 4, 3, 7 will be added again. The pixel size get bigger and bigger. So 4 added here, so 26 and so on. 3 here, 14, 17 become 17 and 20, and 7 added here 28, you get the total pixel value. Okay, so these numbers will be recorded in the computer. The computer, when the doctor turns the image in the computer, when it turns the image, the 3D view to other side, the contrast will change. But let's say like a kidney, let's say we move around, then the color will change accordingly. One get brighter, one get darker. Why it get darker? The computer play around with the pixel values. The 28, in this case, maybe the 20 part will show a more darker color, and you rotate it. So this is how the computer collect the pixel values. So if the final pixel value, you can get the original one by deduct 14. Why deduct 14? 14 is the total pixel value earlier. So what is the total pixel value earlier? 4 plus 1 plus 7 plus 2 is 14. So all the pixel you minus with the total pixel value, the earlier pixel value. So you get 12, 3, 6, 21. Then you divide by 3 dimension, divide by 3, you get the original pixel value.
So why is 14?
Yeah?
Why is 14?
Because the total pixel of the earlier one. You see the body, I go to the original body, how many pixels total? This is 14 one.
So we use 14 and divide it for every case.
For this case, the total is 14. So the total pixel you got finally you got the total pixel, right? This total pixel you minus with the original total pixel, which is 14. This case is 14. Your real exam may be other numbers. Okay. So minus with the original pixel, then divide by 3. Always divide by 3, get the original pixel value. Okay, if this comes out, it's gifted 3 marks, maybe 3 to 4 marks. Okay, just fill up the numbers. Okay, for example, give a try for this. Okay, the pixel given is 3, 4, 8, 5. When it was shine horizontally, how much the pixel will be? 3 plus 4 become 7, 7, 13, 13. Now imagine you shine from this side. So now you shine from this side. So what is the number you get? On this side, this will be 4, 3 and 5 will be 8. This will be 8. So these 3 pixels need to be added here. Okay. This is 4, this is 8, and this is 4, right? This is 8. So added here, how much you get? So you get a certain pixel value. You get what? 4 plus 7 is 11. 8 plus 7 is 15. 13 plus 8, 21. 13 plus 8 is 21, right? Oh, sorry, made a mistake. Oh, yeah. 28. Bottom right corner. 28. Yeah, 8 plus 13 is. Both are 8, 8, right? 8, 8. So 8 plus 13 is 21. 8 plus 7 is 15. 8 plus 13 is 8 plus 13 is how much? 21, right? Okay. So how do you get 28? No. Just 8 plus with 13 only. Okay, 8 plus 7 you got top. Okay, now you shine from the top. This is the current pixel value. And you shine from the top now. What is the pixel added? So 4 plus 5 is 9. 3 plus 8 is 11. So now the 11 and 9 will be added to this pixel up. So what is the new pixel will be? So 9 plus 11, 20, 9 plus 21, 30, 11 plus 15, 26, 11 plus 21, 32. Okay. So this is the current pixel now. Now shine from the side, accumulate the pixel value. Inside will be 3. This will be 12. This will be 5.
I get this value.
Yep.
Oh, I put into this.
Stop. You're doing.
So I calculate this first and straight away add into this
One by one.
one by one.
One by one. So now this, hold on, and this one 3, 12, 5. So put it into this pixel, in the sideways, yeah. Then you get the final pixel. Okay, the final pixel value you'll get. What do you get? Anyone? The final pixel value, whatever you get, you deduct by what? You minus with, what is the total pixel here? 8 plus 8 is 16, so 20. You minus with 20, then you divide by 3, you should get back the original pixel. If you get back the original pixel, that means your calculation for every part, the final part is correct. Real exam, some students ask, why we straight away do the other way around? This answer, just times 3 plus 20, we get the final pixel, right? You can do that if they ask for the final pixel. But in exam, they'll do ask part by part. So you have to work one by one. Okay? So if they ask for the final pixel, you can work from behind. Okay? Okay, so this is the pixel calculation. Okay? Okay. So maybe the slide is a lot. I tell you the only thing you need to remember is this part. How the CT scan works. Okay. You need to memorize like MRI. Okay. So CT scan, a slice of image at different angle is produced. Okay. These images are combined. Okay. And repeated for many different slices. The first slice, they take imaging at different angles. Then they repeat for next slice. Okay, they repeat the same, taking the image at the next slice. Okay, to build up 3D image can be rotated. Computer required a greater storage. Yeah. So why the CT scan different from X-ray? CT scan takes a slice of image at a different angle, 1 mark. These images are combined, 1 mark, repeated for many slices, 1 mark, to build a 3D image, which can be rotated. Okay, and to have this idea, you need to have a powerful computer. So early years, not possible, but now currently our computer is quite powerful. So now it's possible to have a CT scan. Okay, so on top here, what is the difference between CT scan and the X-ray is? CT is slices of image can be combined to form a 3D image. X-ray is it's a shadow image, it's a 2D image. X-ray is a 2D image. CT scan is a 3D image. Okay, X-ray shadow image, CT we can say it's like a built up from a slices of images forming 3D. Okay, so this is what you need to remember for CT scan. I need to know how to calculate these pixels. Okay, so this is the part you need to remember. Okay, if you're interested, you can read the front slide, a lot of information, but we won't ask. The only one they will ask is final how it works. Okay, let's memorize this. Okay, so I stop here.